by how many cubic units it would take to fill a given space. A cube shaded green is a cubic unit. The amount of cubic units it takes to fill a defined space is what we call volume. The shown geometric solid is a rectangular prism. To find the volume of any rectangular prism, we simply multiply the length times the width times the height. The length and the width of the rectangular prism are always at the bottom of the shape. These two dimensions make up the base of the rectangular prism. In this case, the length is 4 and the width is 3. Multiplying the length times the width will give you the area of the prism's base. This is a two-dimensional measurement. After multiplying the length times the width and getting the area of the rectangular prism's base, by multiplying it by the rectangular prism's height, that will give us the volume. Multiplying the area of the prism's base by the height is filling up the prism or adding depth. This is what gives our rectangular prism a third dimension, or gives it volume. We can clearly see when multiplying the length times the width of the rectangular prism, we come up with 12 square units, which would be the area of the rectangular prism's base. Remember, this is only a two-dimensional measurement. To give it depth or volume, we must now multiply the area of the rectangular prism's base of 12 by whatever the height is to fill up the rectangular prism or to add depth or volume. If we multiply the area of the base, which is 12, by a height of 1, that would give us 12 cubic units, which would be how many cubes it would take to make one level of our rectangular prism. Adding 2 levels of 12, we would get a total of 24 cubic units. 3 levels of 12 would give us 36. 4 levels of 12 give us 48 cubic units. And of course, 5 levels of 12 would give us 60 cubic units. We could say that each level of the rectangular prism contains 12 cubes. There are 5 levels of 12 cubes for a total of 60.
Alright, we're going to talk about volume for 3D shapes. The definition of volume is measured by how many cubic, I forgot to delete this so you can just cross it off right here. It's measured by how many cubic units it would take to fill a given 3D object. Some examples of volume are how much water would go in a pool. It could be how many chips could you fill in a bag, or how many crackers could you fill in a box. Volume, we're going to talk only about prisms in 6th grade. You can find the volume of any 3D shape, and there are lots of formulas, but we are only going to talk about prisms in 6th grade. A rectangular prism, you can use a formula that it would be length times width times height equals volume. So length times width times height is volume. Or area of base times the height. I like this formula better because this formula will apply to every single prism. So for example, this rectangular prism here, the area of the base is going to be length times width. So the area of the base is going to be right here, this rectangle at the bottom, what would be touching the ground. So the area of the base is going to be 12 times 5. That's the area of the base. The height of the rectangular prism is 3. 12 times 5 is 60. 60 times 3 is 180 inches cubed. We will talk more tomorrow about why the units are cubed or to the 3rd power. But anytime we talk about volume, it's going to be the unit to the 3rd power or the unit cubed. All right, for a triangular prism, this is a triangular prism. Remember that a triangular prism has 2 faces that are triangles and then 3 rectangle faces. To find the volume of a triangular prism, it's area of base times height. The base of this triangle, so I'm going to write that here. I'm going to write base times height. And I guess I really should write area of, it really should be area of base times height. The base on triangular prisms are always the triangles. Even though the rectangle is what's resting on the ground right now, on triangular prisms, the base is always the triangle. That means we are going to be doing 1/2 times base times height. So 1/2, my base is 4, the height is 3. 1/2 times 4 is 2. 2 times 3 is 6. Then I multiply it by the height. This is the height, which is 11. So I'm going to do 6 times 11 is 66 centimeters to the 3rd power, or cubed. That would be the volume of this triangular prism. All right, we are now going to look at any prism. So remember, any prism has 2 faces of the same shape, and the rest of the faces are rectangles. And for any prism, it's the area of the base times the height. Our base on this prism has 1, 2, 3, 4, 5 sides. That's a pentagon. And so we're going to have to decompose this into recognizable shapes to get the area of the pentagon, the base. I'm going to divide it into triangles. And I have 1, 2, 3, 4, 5 triangles. This is also 5 inches. So for the area of one of the triangles is going to be 1/2 times 4 times 5. So one of those triangles has an area of 1/2 times 4, which is 2, times 5, which is 10. So that triangle is going to be 10 inches squared. This one will be 10 inches squared. This one, this one, this one. So the area of the entire pentagon, or the base of this pentagonal prism, is 10, 20, 30, 40, 50. So the area of the base is 50 times the height, which is 8 inches. So times 8. 50 times 8 is 400 inches cubed, or to the 3rd power.